Hello everyone. We are starting today our new series on structural design patterns. And the first pattern to cover is the adapter pattern. Imagine a situation, real life example, you you have purchased your laptop in US, but you just arrived to Europe, to CERN, to work here, and you would like to charge your laptop. Well, it will be sort of problematic on the spot because your charger is not for Europe, it's for US. So your plug is not created for Europe. What you will do, you will use an adapter. You will not change your charger, you will just put your adapter on your plug and you will solve this problem in this very simple fashion. The same solution is proposed by an adapter pattern. You have your old interface, you have new interface that you want to move to. So what adapter will do, it will be like a wrapper around old interface to be able to use the new one. And that's it. Um, Let me give you an example. Imagine we worked with CPU, GPU or TPU units, and now because of D-Wave or because of some other companies, we are able to move to quantum machines. So we have all three types of machines and new QPU machines. What we will have as a link in between is an adapter, which basically wrap all the interface to be able to call it with the new interface of QPU. And this is an example around which we'll be dancing today. And of course, just to practice some polymorphism, we'll cover adapter with polymorphism today. And here is a set of steps that we will follow. So first we'll specify the new desired interface of QPU machines. Then we'll design a wrapper class that can match the old interface to the new one, which is CPU, graphic processing units, tensor processing units to QPU. And as a part B here, it's basically the adapter or wrapper maps what we need now to the legacy implementation. And finally, clients are coupled to, they use the new interface. And this is what we will have in our main function. With that, let's dive into the code. And we will start with the class for new interface. In a public session, in this section we will implement the first rule. Let's have new interface constructor. Let's have a virtual destructor. And let's have finally the sweet spot of this class, which is a function, a new interface function that we'll have to use since now, because those are new machines. So we can say those are QPU machines. And this virtual function that returns void we'll call very simply run new interface. And it will be purely virtual, so we will have to override it. And that completes our new interface implementation for QPU machines. Basically what we'll have to do, we'll have to make adapter to be able to map old code to this run new interface. So when we call run new interface, we can work on QPU machines using the functionality that we had before in our legacy code of CPU, GPU, or TPU. Okay, now into part B. Since in general it's not clear how many old classes we've got, it's a good programming practice to have a template for all the possible, sort of all the possible classes that we had before. So let's have a template class, and we'll have different types of classes. More precisely, in our case, we'll have 3, but of course it can vary. So we'll have a template class which we'll call applyAdapter, so the name says it all, which will publicly inherit from the new interface. And in the public section, we'll have our constructor. Now, what I would like to use in this constructor, and this is the most logical, is the following. We are dealing with a class, so there are objects of this class. But also we will have to call a function upon it, so we have to have at least 2 items. We need to have an object and we need to have a member function. So this is what we will have here. We will have an object and we will have member function. Now let's define them. And I will do it in the private section. I will say that of the type of whatever class we used, we will have a pointer to that type. So it's pointer to object. And also we will use a functor, right? We will have from this type, don't forget the reference operator, we will use a method. So what we have here as a member, as an attribute of our templated class applyAdapter, we are having here a pointer to member function. With that, we can now finalize our applyAdapter constructor. So we'll say we'll have a type, whatever class type we had. We have pointer to the type. We'll call it object, which is object in, right? The whatever old interface we put in, whatever old plug that we have to deal with, and now functor of the type, whatever type we had. Don't forget again the reference operator and braces. And now inside of the body, what we will do, we will assign our member fields to the objects that we pass in. So object will become an object of whatever old class that we had, and our method will be whatever method that we had before. Alright, that concludes our constructor. What about destructor? Well, this is way simpler. We just delete whatever object we allocated, and that's it. Alright, now finally we can move to a bit more interesting part, which is 2b, and this is where we map old interface to the new one. And this is how we do it. So we'll have a function, let's say run new interface, which we actually defined before, so maybe I'll save some typing using code generation. So we will override it in a very simple fashion. We'll just use the functors that we stored. Now remember, how would you call this functor? You would do it in the following way. You will use the reference operator, and then you would put the name and whatever parameters you have, but we have none. But don't forget that this is our member function of a class, so this should be called upon an object. So what we should do, we should take an object and call upon it our method. But this is a pointer, so we need to dereference it. And this is how the final version looks. Okay, let's do a quick sanity check to make sure everything is in place. We start with a template class. We define this specifically applyAdapter class to inherit publicly from new interface. Now we have constructor where two private members of applyAdapter object we assign object in to the method member function in. Those are functors. Don't forget the reference operators, which are very important. We have a simple destructor which deletes an object, and we have overridden run new interface function from the parent class new interface, in which we take a member attribute that is storing object that we pass in, and upon that calls an old method that we already pre-computed that we stored before in a constructor. Finally, our member fields. Alright, so far so good. Now let's have 3 totally incompatible interfaces, which are CPU and graphical and tensor processing units. And we will keep it as simple as possible just to illustrate an example. So we'll have class CPU, which is publicly contains, let's keep just destructors, in which we will put a couple of, well, just one cout. We will say CPU destructor is here, is called, right? Is called, okay. And also we will have here a very specific to CPU function, and you cannot find a more specific name that I'm suggesting, which is run on Intel. And Intel is, I guess, one of the main manufacturers of CPU. So this is a sign that this function is very, very specific to CPU. And we'll have cout run CPU function run on Intel. All right, that concludes our implementation of CPU. Now let's do the following for GPU. So GPU, but for GPU, I think the main manufacturer is NVIDIA. So we'll call it right like this. Run. Let's remove run. So when you call the function, it will be clear. GPU function run NVIDIA. Okay. And now finally, TPU. Let's have some TPU. Let's say involve TPU function, which we'll call run on Google. right? Because Google is working with TensorFlow. Run on Google. All right. So those are three totally different interfaces, and actually it's one of the challenges that LHC has to face soon when we will be moving to new architectures. Hopefully one day we will move to QPU. I'll be super excited to work on that, of course. So now, uh, let's start working with our QPUs. So here's how we can do. We can initialize new interface, which is pointer to pointer. And we'll call it initialize QPU. And here's what we're gonna do. We'll start with array pointers. For example, we'll have, here is a pointer to a new interface, and here is our array signature. We'll have new operator to produce a pointer, and we'll have 3 of them. So it produces an array of pointers of length 3. Now let's start populating the array. We'll have new, and now we apply adapter on, let's say, CPU. So we'll be able, working with QPU, to involve functions developed for CPU. So how we would do it? Let's look at how we construct apply adapter object. We need an object, and then we have functor. And this functor is a pointer to member function. So that means we need an object, a pointer to new object, CPU, and we need a pointer to a member function, so reference sign CPU run on Intel. Let's see if it can find it. Not really. Okay, we'll do it manually. And now we'll repeat it a few times for the other architectures. So we'll use GPU and TPU. And of course we'll have to modify member functions that we passing. So what we've done? We've done the following. We created an array of pointers where we store our apply adapter objects. And these apply adapter objects, they are already designed to work with old architectures. So once we pass in old architecture, we can always, on apply adapter, run new interface that will use an old object and a non-member function and will make sure that it runs smoothly. And after that, we return this array. And with that, we can finally move to the final point, which is, let's define a client. So let's have auto objects. We'll do initialize QPU. Now let's have a loop for int I equals, let's say, 0, and we have only 3 objects, so let's then 3 plus I. What we will do, we will invoke our function run new interface upon each object, because as we just discussed, it's already designed for the case that we have old interface, but we will be able to run new customized function so that we can initialize a new one. We can work with a new interface, right? So that is done. Now, and this is like an example of polymorphism again. We can have a loop where we will be destructing the objects that we've got. So we will just call delete on whatever object that we work with. And finally, after we delete every single object, we will delete the whole storage construct, which is our array here, array of pointers. And let's go ahead and run it. So let's go step by step. First, we initialize QPU. When we do it, we basically create 3 objects. Now we loop over and we run new interface. When we run new interface, we take each object and we run its specific, and I need to stress it, its specific method upon it. And when it happens, for example, for CPU, we will run on Intel. So when we run on Intel, what will happen is that it will say run CPU function run in Intel. And this is what gets printed. And then we'll have GPU run on GPU or in, and finally TPU. And finally, once it's over, one by one, CPU destructor, GPU, and tensor processing unit destructor are called. This is how we've done it. Let's have a quick recap. We had 3 old interfaces, CPU and graphical and tensor processing units, and we are going to move to quantum machines. So we would need an adapter. How we worked through this? Well, first we specified new desired interface, and this is for QPU machines where we have to run on new interface. So it's some function that we will be running on QPU machines. And then we designed the wrapper class. However, since we had unknown or 3 in particular old classes in our example, we decided to start with a template class. So this class inherited publicly from new interface, and in the constructor we saved old object and old object an old class member function. Why we need it? Because in the new run new interface function we are invoking whatever old class we used before, function, member function, all the object of that type. And finally we developed 3 old interfaces because we are using it for our example. Also we defined this helper function initialize QPU, which is basically a storage for 3 different objects, and also see how we stored it. So we put a pointer to each particular object and a pointer to each particular member function. And then, just one by one, we run new interface on those objects. It worked fine, as you can see print out here. And then one by one, we deleted it, and ultimately we deleted the whole construct. So this is how you do it. When you have an old interface, you develop an adapter so that you can run on a new interface, and the problem of moving from old architecture to the new one is solved using this design pattern. Here is how you use adapter. Hope you enjoyed it. Stay humble, stay hungry. Till next time.